Hello. So we're going to continue with number 11. And number 11 is about dog food. So the chicken has, the dog food has chicken and grain. And we have to find out what's the proportion should be so we can have um, minimum cost. So this is the question. You need to find the minimum cost. So first we need to get the function which you're going to find the minimum. And the minimum, we need to find the minimum of the function cost. And using the numbers they give us, 11 ounce per chicken and 1 cent per for the grain. Let's say we're gonna name also, let's say the grain. We're talking about chicken. So let's say the chicken is X and the grain is Y because they're always talking about the chicken first. So I'm gonna say, let's say X is the chicken. It doesn't matter in this case because it doesn't say what is what, but we're gonna pick X for the chicken and Y for the grain. So calculating or writing the cost function is gonna be 10 cents per chicken. So it's gonna be we're gonna change the cents to dollar amount, 0.11x plus 1 cent is going to be 0.01 y. So this is the function which is going to calculate the cost, and you have to find the minimum. You have to minimize that function. Okay? So now, how are you going to do that? We need to use the restrictions. We need to find the area and then get the corner points on that area. So we have, first let's focus on the protein. So we have at least 230 grams of protein. So the protein at least means minimum. So that means whatever we get has to be greater or equal to 230. So now we have chicken has 10 grams of protein. So it's going to be 10x plus the grain has 2 grams of protein. So it's going to be 2y. So that's going to be the equation. So I'm going to put 10x plus 2y has to be greater or equal than 230. And then the second inequality, we're going to use the information given for the fat. So we have to have at least means greater or equal 170 grams of fat. And let's see what it says. The chicken has 5 grams of fat, so it's going to be 5x. The grain has 2 grams of fat, so it's going to be 2y. And that's going to be the second inequality. So you have 5x plus 2y has to be greater or equal 170. And again, you're going to have x and y greater or equal 0 because it's a word problem. X and y has to be the ounces for the grain and for the chicken. And this always have to be greater or equal 0. And this is the system we're going to find. We're going to graph. We're going to find the region here. We're going to find which one is which one are the corner points, and then you're going to calculate the minimum. I'm going to show you actually how to find the minimum. So taking all these two, actually 4 inequalities, when I graph them here, this is what I have. So this is how the area looks like. And we have the corner points are going to be 0, 1, 50, 15. The other one is going to be 12, 55. And the third one is 34 and 0. So those are the numbers I'm going to use to calculate the minimum. This is it's open, unbounded area, but because we're looking for minimum, we can find the minimum now. So this is how you find the minimum. So here I'm going to insert a table. usually when I set it up in a table, it's going to be easier. So I have 3 corner points, and I'm going to use a table which is going to have 3 columns. And in the first column, I'm going to put, let me make it a little bigger. So the first column is going to be the X. The second column is going to be the Y. And then in the third column, I'm going to find the minimum or calculate the minimum of the cost function, which is 0.11x plus 0.01y. Let me fix this table. We're going to put x and y. Those are going to be the coordinates for the corner points. And the corner points we got, I have it here. You can go back and look at them, or you can just pause and see. So I have 0 and 115. The other one was 12 and 55. 12x and 55 is y. And the third one is 34 and 0. And also the corner points from the graph. Now, finding the minimum means plugging x and y from each corner point into the cost function. So calculating the cost for all these corner points. So when I replace x with 0, it's going to be 0.11 times 0 plus 0.01 times 115. And when I calculate that, we're going to get 1.15. That's going to be the cost if I use these proportions for the chicken and for the also that means if I use 0 ounces chicken and 115 grain. So let's do the next one. Next one, I'm plugging in the cost function. I'm plugging in, so I have 0.11, replacing x with 12 and y with 0.1. Replacing y is 55. So when I calculate that, I'm gonna get, let's see what I'm gonna get. So I have 0.11 times 12. That's 132 plus and then I have 0.01 times 55, it's 0.55. And when I add it together, I'm gonna get 187. So this is the price if you do the second corner point. And then the last one is gonna be if I plug it in into the function, into the cost function, 0.11 times 34 plus 0.01 times 0. And this here is going to give me what's going to be the price if you don't use a grain, if you use only chicken, which probably should be the most expensive one. And when I multiply those two numbers, that's going to be $3.74. So now looking at those three numbers, 115 is the first number we get. The second one is 132. I'm sorry, no, the second one is 187. That's what we get in the end. And 347. Looking at those three numbers, which one is the minimum price? Because you're looking for minimum. Which one is the smallest one? Smallest one is 115. So 115 is going to be the minimum price, the minimum cost for that dog food. Now, they are not asking what is the minimum price. They're asking what is X, what is Y. They're asking how many ounces of chicken and how many ounces of grain you're going to use. So now we're going to put those 0 and 115 is going to be the answer. Now, that's why I put X and Y in front of the chicken and the grain, because the grain is the Y. So it's going to be 115 grain and 0 chicken, because chicken is more expensive, that's why. So if they want to produce, if you want to be, I mean, you're the manager there, right? So if you want to have the minimum price of the chicken with the price, the minimum price, the minimum cost of that dog food is going to be if you use 0 chicken and 115 grain. So if everything is grain. So that's how you do that. The next question is the same way. Just here, instead of chicken and grain, you're going to have two different types of ice cream, vanilla and mocha. So we're going to plug it in here. We're going to start with the setting of the, finding the, how many quarts of each flavor should we make to earn the largest profit. So you're looking for the maximum profit, right? So the maximum profit, we need to set up the profit function, which in this case, we're going to look at the price. So here first we need to decide what is X, what is Y. So let's say vanilla is X and the Y is going to be the mocha flavor. So X is the vanilla and Y is the mocha. Now each vanilla cup is $3. So it's going to be 3X plus the mocha is 2Y. So this is the cost function. We need, this is the profit. I'm not the cost, sorry. This is the profit function. This is how you're going to calculate what's going to be the profit for you. And you need to find the maximum profit. Now we need to set up the inequalities here, and we're going to use the X, restriction for the X, and restrictions for the cup of cream. So we have in stock 500X. So that's the maximum X you can use. So everything you do should be less or equal 500, and everything you use should be less or equal 900 cups. So now we're going to start with X first. So we're going to have for the vanilla ice cream using 2X. So it's going to be 2, sorry, the vanilla is X. So it's going to be 2X plus 1Y has to be equal, less than or equal than 500. So I have 2X plus 1Y, just Y, has to be less or equal 500, because 500 is the X you have. You don't have more than 500X to use. Okay? The second inequality is going to be about how much cream you have. So you have 900 cups of cream. So it should be less or equal to 900. And we have 3 cups of cream. So it's going to be 3X for vanilla plus 3Y for the mocha. And that's going to be my second inequality. So 3X plus 3Y has to be less or equal 900. And also because it's a word problem, of course you have to have X and Y less or greater or equal, greater or equal 0. They have to be positive numbers. That's why you need to do that always if you have word problem. So these are the restrictions. These are the inequality, system of inequality you have to graph, and then you have to find the corner points. And then using the corner points, we're gonna evaluate, we're gonna calculate the the maximum profit for this one. So now let's start with graphing this. So I'm gonna go to the to the Desmos calculator. We're gonna put 2X plus Y has to be plus Y has to be less or equal 500. 500. And then you have 3X plus 3Y. You're changing the second one. Has to be less or equal 900. And then, of course, you have the other one, which X and Y are positive numbers. And then looking at my picture, this is what you have. We have 3 corner points. So the area is bounded. So this is one of them, 0, 0. This is the other one, 250, 0. And the third one is going to be at 300, 0, 300. So those are the 3 corner points we have. And we're going to use those 3 corner points to calculate the profit and see which one is the biggest one. Okay, so here I'm going to insert a table. And in that table, I'm going to use 3 corner points. And I'm going to set it up like this, a little smaller. So I have X, Y, and here you need to find the maximum of the profit is 3X plus 2Y. This is where you're going to plug it in to see which one is the biggest number. So let me make this smaller. We're going to use X. X is, we're going to use 0, 0. Of course, that's going to be the minimum. 0, 0. The answer is going to be 0. When you plug it in 0, it's going to be 0. Then you have the other one is 0 and 300. Oh, we need one more actually. You have the intersection. I forget that point. We have 250 and 0. And there is one more. Okay, let me show you. There's one more. We have one more over here. This is the point we're going to use, this one. And this point is 200 and 100. There are 4 points. Okay, so let's use 200 and 100 in here. I need one more. Okay, I'm going to delete the last one. We have 200 and 100. So we're going to plug it in. The first one, when I plug it in, 3 times 0, 0, 2 times 300 is 600. Then the other one, we have 3 times 250 is 750, plus 0 is 0. And then you have 600 plus 800. It's going to be 800. And actually, let me write it down how I get this. So I'm going to have 3 times 0 plus 2 times 300. That's 600. Then we get 750 when I get 3 times 250 plus 2 times 0. You plug it in into that function. That gives us 750. We get 800 when you did 3 times 200. Oh no. This is coming out. Sorry about that. So I have 3 times 200 plus 2 times 100. And that gives us 800. So now, looking at these 4 numbers, we get 0. We get 0. The other number we get is 600. The other one is 750. And the last one is 800. Which one is the biggest one? Obviously, 800 is the biggest one. And that's your answer. Now, here they're not asking for the answer. They're asking how much X, what is X and what is Y? So technically, they're asking for X and Y. This should be the answer. Okay, so now how many ounces vanilla and how much we need to get? So vanilla was X, so it's going to be 200. I just want to put everything in the same place. The mocha is going to be 100. So those are the answers. X was the first one and Y is the second one. Okay, so those are my answers, 200 and 100. Now, looking at number 13, and 14 and 15, we have 3 more. 13, they're saying that in linear programming, the problems we're solving, if you have unbounded area, if the region is unbounded, how many solutions do you have solutions or have no solutions? Now, if it's unbounded, if you're looking for minimum, yes, you have solution. If you're looking for maximum, there's no solution. So that's why the answer here should be you may or may not have a solution. Okay? So that's the answer for this one. Number 14 is the same way we did with the vanilla and the mocha ice cream. You set up the system here and solve it. And then the last one is another one where you have to solve it. I'm going to show you here the solution real quick, and you can just practice by yourself. It's pretty much here. This is popping out. Okay, there you go. So we have 15. Just did that. 15. This is the solution for 15. I did it by hand. So those are the corner points, 0, 160, 60, 80, 160, 0. And then we're looking for minimum. It's open area, unbounded, but you're looking for minimum, and the minimum is at 60 and 80. Okay, so this is the solution. You can look at it. And then the last one, it's we have to find if it's if you have bounded or unbounded area. So when you graph this, if you graph this, you're gonna see that is gonna be is gonna be bounded, and that means you have optimal solution. Okay, so this pretty much concludes your handout, and pretty much it's gonna help you with your quiz 7. And good luck with it. Good luck in the final exam. If you have questions, just email me or text me. Okay, send me email or text me on my cell phone. Okay, have a good day.